This is a short video to show off the Morse code decoder and keyer project that I just completed. The video is intended for some of my friends who are hams and some of my friends who are not hams, so I may explain a few things in a little more detail than is necessary for the hams. I hope you'll forgive me for that. This is a quick view of my overall setup. And this is the little keyboard that will work with my decoder-keyer combo. And there's a Bengali iambic key sitting to the right of the little keyboard. You won't be able to see the keyboard later when I'm actually using it, so you get to see it now. This is the decoder-keyer itself. It has two screens, as you can see. The top one is a 4-line screen that displays whatever the decoder is decoding, incoming Morse code. The bottom screen displays whatever I type on the keyboard or send on my keys. You can see at the top line here says words per minute, currently set at 15. That's pretty normal on a decoder. One thing that's different about this one is that I can change the words per minute by turning this knob here, but when I do turn the knob, you can see that I've changed it to 18 up there, and I don't know if you can see this or not, but it says L54 down here. What it's doing is telling me that the element size has been changed to 54. That means the dot will require 54 milliseconds. Everything in Morse code is based on the size of the dot. So I've never seen a coder that actually showed you the size of the dot before, but I wanted to put that on mine because that's really what everything's based on. I wrote this based on the Paris standard. The word Paris happens to have just the right number of Morse code elements in it, that if you were to send it 20 times in exactly 60 seconds, and you sent it perfectly, every element would be 50 milliseconds long. That's what the Paris standard means, and that's how they relate the milliseconds to the number of words per minute. It's basically a ratio based on that. You can see here that it says N24. That's the number of samples that the software will take of the incoming audio stream. It takes 24 samples. The number of samples can be changed by pressing this button here. Now I've got 36 or 48 samples. It also does 64 or even just 12 samples. That helps tune it to the quality of the incoming signal. The thing here, TF558, that means the target frequency. That's the frequency target that I'm looking for on the incoming signal. And that can be changed with this frequency button over here. Now when people send Morse code, it's called on the side tone, you'll set it for 600 or 500 or 700, 800, 900 or 1,000. Usually it's one of those. In this case, it says 558. Well, that's basically 600. It says 558 because the nano computers that I used inside this thing, that's how the signal works out for even numbers based on the clock cycles in the nanos themselves. And I could have rounded it off when I put it up here, but I didn't. I just left it. That's the real thing, whatever it says up there. But that's about 600, and that's close enough. There are two nano computers in this thing. The top one nano computer handles the decoding up here, and the other nano handles the keying input down here. Both of those have to do, whichever one is going to be Morse code, so they both have to be decoded in order to put alphabetic characters on the screens. So, rather than duplicate the code, I made a serial link between the two nanos. So when I send code on one of the keys or the keyboard, that code goes to the other nano, which decodes it and sends the alphabetic characters back to the first nano, the keying nano, for display on the screen. This button here is just a dimmer switch for the big screen. It'll dim it and make it brighter. The bottom screen doesn't have that ability. You already know what the words per minute knob does, but if I press the word per minute knob, it'll boot both of the Nanos at the same time. And that's actually done through the software rather than a hardware link, which is kind of different. This button here, this is a switch. That's the DIT switch. An iambic key has two levers, one for the dot, one for the dash, and the DIT switch lets you pick which one you want to have the dot on. There's a key, there's plugs down here, one for the straight key, one for the paddle, and that's basically what it has. There's you can have headphones on there. On the back, you'll see the plugs for the keyboard and the audio input, stuff like that. Let's see if we can make this thing work. See, it puts it on there when I send it on my key rather than on the keyboard. You can see I can manage it with the straight key too if I'm lucky. This is some incoming Morse code being transmitted by W1AW. You probably can't read it, but it says it wouldn't have worked anyway in the end, period. Messages were passed and transportation arranged, and at that point the signal got bad and didn't get any more of it, but they read from documents of various types, stories or magazine articles or whatever, and send it out as practice for people to practice their Morse code copying. Anyway, that's what it does, and hope you enjoyed it.